Welcome back, guys. अब हम करेंगे kinematics question 5, paper 2. Sorry, I'll change that in the next video. So paper 2, question 5. Let's start. Question 5. Figure 7.1 shows a child sitting on a sledge on a snow-covered hill on of constant slope. एक constant slope की hill है and एक बच्चा sledge से slide करके नीचे जा रहा है. At time t is equals to 0, the child and the sledge begin to move down the hill in a straight line. When the child sees a wall ahead, he applies brakes. मतलब उसने देखी है एक wall and he applies the brake. The child and sledge continue to travel in a straight line until they come to a stop before hitting the wall. Before hitting the wall मतलब यहाँ को जाके वो they stop before hitting the wall. यहाँ कहीं भी जाके हो सकता है लेकिन I'll assume it's near the pole. The brake is applied at t is equals to 26. Figure 7.2 shows how the speed of the child and sledge varies over the whole journey. Explain. Explain why between t0 and t26 the speed varies in the way shown by the graph. First of all, for the first few seconds, the acceleration is constant because there is no backwards force. ठीक है ना? There are no backwards force, right? The only force which is acting is the component of weight, which is acting in this direction. ठीक है ना? That is gonna be the only force which is acting for the first few seconds. That's why the velocity is constantly increasing. But after a certain time, the velocity starts to increase but at a lower speed, at a lower pace. That means the acceleration is decreasing. ठीक है ना? Acceleration time graph would look something like this. ठीक है ना? That's what a acceleration time graph would look like if the acceleration is decreasing. यहाँ acceleration constant थी. ठीक है ना? यहाँ acceleration time graph would look something like this. ठीक है ना? बट यहाँ जाते जाते acceleration is decreasing. That means कि एक टाइम पे आके टर्मिनल स्पीड पे पहुंच गया है. The kid has reached a terminal speed which is this point from this point. The kid has reached a terminal speed. That means the forward forces are equal to the backward forces. Backward forces क्या होंगी? Air resistance or the friction. Air resistance and the friction. ठीक है ना? That are the backward forces. Then eventually the kid starts to apply brakes and he starts to decelerate at a constant deceleration. Acceleration पे एक constant deceleration है. ठीक है ना? There is a constant deceleration. जैसे constant acceleration नहीं होता वैसे ही constant deceleration भी होगा. Okay, so I have explained everything to you. So let's see the answer. Question 5A. Question. Okay, this is the answer. अच्छा, acceleration, increase in speed and gravity slash weight are mentioned. Air resistance, friction increase. Air resistance and friction increase with the speed. All the friction decreases with the speed. But air resistance still increases. Terminal velocity, constant velocity reached और air resistance become equal to the accelerating force. जो एक टाइम आएगा जब the force of weight will become equal to the force of air resistance. ठीक है ना? So this is the answer. B. At 26, the front of the sledge is 35 meters away from the wall. अच्छा वो बोल रहा है it is 35 meters. My bad. It is 35 meters away from the wall. Just assume. We're just assuming here कि इतना है. This is 35 meters लेट्स जस्ट असूम, ठीक है ना, यहाँ 35 मीटर्स हो गया, ये सेकंड 26 पे है, ठीक है ना। इस टाइम पे जाके इस टाइम पे जाके ही सेज के 35 मीटर्स अवे है फ्रॉम द वॉल, ठीक है ना। एंड दे हैव मेंशनड, दे the child and the sledge continue to travel in a straight line until they come to a stop before hitting the wall. It is before hitting the wall, and at 26 seconds before the the sledge starts to decelerate, हमने वो निकाल लेनी, एरिया अंडर द ग्राफ निकाल लेते हैं। अच्छा, एरिया अंडर द ग्राफ कैसे निकालेंगे? वन विल कैलकुलेट दैट बाय 1 डिवाइडेड बाय 2 इनटू, ये क्या होगा, ये हमारे पास ये आ जाएगा हमारे पास, ये होगा तकरीबन, अच्छा, ये हर जो ब्लॉक है ना इट्स रिप्रेजेंटिंग 0.4, तो ये 12.4, 12.8, 13.2, 13.6, 14, 14.4, 14.6, 15.2 हो जाएगा। इट विल बी 15.2, द हाइट विल बी 15.2 मल्टीप्लाइड बाय द बेस, बेस विल बी, यहाँ है 26 से शुरू हुआ है और 30 पे खत्म हुआ है, तो बेस विल बी 4, so this will come out to be as 30.4 meters. अच्छा, they said कि 35 meters पे इट लाइक जो चाइल्ड है और द वॉल का डिस्टेंस है 35 मीटर्स एट 26 सेकेंड्स 26 पे, ठीक है ना। बट द चाइल्ड कम्स टू रेस्ट एट सेकेंड 30, 30 सेकेंड पे रेस्ट पे आ जाता है। सो दे आर आस्किंग फॉर द डिस्टेंस बिटवीन द चाइल्ड एंड द वॉल, जब वो अपने स्टॉप पे आ जाता है, व्हेन द चाइल्ड स्टॉप्स, तो उसका डिस्टेंस बता रहा है। फॉर एग्जाम्पल द चाइल्ड कम्स टू अ रेस्ट एट दिस डिस्टेंस विच इज एक्स, ये डिस्टेंस हमने निकालना है बिकॉज द चाइल्ड इज नॉट हिटिंग द वॉल। हमने ये डिस्टेंस निकाल ली है वेयर द चाइल्ड कम्स एट रेस्ट, वी हैव द टोटल डिस्टेंस which is 35. If we minus 35, if we subtract 35 from this distance at which the child has come to rest, will we get the distance x, the distance between the child at rest and the wall? That is what we're looking for, and we'll get 30.4, which will be 4.6 will be the distance between the child and between the wall. Acha, see, at t is equals to 26 seconds, the child and sledge begin to decelerate. Determine the size of deceleration. Acha, if we're gonna find the deceleration, we'll have to calculate what the gradient is. And to calculate the gradient, we need to apply the formula y2 minus y1 is equals to x2 minus x1. अच्छा, हम यहाँ से यहाँ तक का ढूंढ रहे हैं ना, तो हम पहले इसका ले लेते हैं, इसके कोऑर्डिनेट्स ले लेते हैं, ठीक है ना। इसका ये होगा 26, एक्स एक्सिस पे 26 होगा, एक्स विल बी 26 एंड वाई विल बी 15.2 एज वी प्रीवियसली कैलकुलेटेड। और उसके बाद अब इसके कोऑर्डिनेट्स निकाल लेते हैं, इट विल बी 30 एंड वाई विल बी 0। तो अगर हम फॉर्मूला अप्लाई करें y2 माइनस y1, y2 इज 0 माइनस y1, y1 इज 15.2 divided by x2 minus x1, x2 is 30 and x2 is 30 and y2 is x2 is 30 and x1 is 26. So 30 minus 26. अच्छा, this is, अच्छा, ये 15 हो जाएगा, माइनस 15.2 आ जाएगा, माइनस 15.2 डिवाइडेड बाय, अगर हम नीचे सब्ट्रैक्ट कर देंगे 30 minus 4 will get 4. This will give us minus 3.8 will be the magnitude of deceleration. Let's check. Minus 3.8. Yes. शुक्र है सही है. -3.8 will be the magnitude of deceleration, and we have calculated by using the gradient formula. Minus, it will be in -3.2. It will be in minus because the deceleration is negative meters per second square. You also have to mention the unit. ठीक है ना? So this will be the answer. Part 2. The mass of the child is 46 kilograms and the mass of the sledge is 9 kilograms. Calculate the resultant force on the child and the sledge as they decelerate. अच्छा, इससे हम कैसे निकालेंगे? F is equals to ma से निकालेंगे. F will be the quantity we have to reduce, निकाल लिया हमने. M will be the combined mass of the child and the sledge. That is 55 हो जाएगा अगर हम इन दोनों को ऐड करते हैं. And we'll multiply that by -3.58. ठीक है ना? So we'll get a value of, let's calculate, we'll get a value of 209, which is the correct answer. It is just rounded off. 210 will be the answer. And the resultant force, ये जो negative का sign है, is solely representing what the direction is. ठीक है ना? तो we have to ignore that. ठीक है ना? This will be the answer. And this is the working. State the energy transfer that is taking place as the child and the sledge decelerate. As the child and the sledge decelerate. अच्छा, child is using brakes. He apply brakes. जब अब brakes apply होती है ना, तब the kinetic energy is turning into what energy? The heat energy is turning into heat and frictional force. और फ्रिक्शनल फोर्स क्या करता है? ये फ्रिक्शनल फोर्स पीछे की तरफ को होता है, राइट? इट्स ऑलवेज टुवर्ड्स द बैक. तो इट इज टर्निंग द काइनेटिक एनर्जी इनटू फ्रिक्शनल, and by frictional I mean heat, from kinetic energy and gravitational energy to thermal and no intermediate energy. So that is the right answer. Moving on. At 26, when the brake is first applied, the child jerks forward on the sledge. अच्छा, अगर आपने कोई, मतलब अगर आप गाड़ी पे ब्रेक लगा रहे हो and you like suddenly, अगर आप constant speed पे जा रहे हो ना, you won't like experience, आपको feel नहीं होएगा deceleration या acceleration, so you won't get the feeling of moving आगे और moving पीछे. But when you instantly apply a brake, अगर आप कोई कहीं स्पीड पे जा रहे हो and you instantly have to apply a brake, even if you're at a constant speed, when you apply the brake, you'll feel a sudden jerk आगे. ठीक है ना? आगे को आपको एक jerk feel होगा. That's why sometimes when the cars are driving at a very high speed और आगे कोई speed breaker आ जाता है या कोई भी चीज आ जाती है, कोई बंदा आ जाता है, and you have to stop immediately, आपका या तो पूरा शरीर आगे होता है या आपका सर आगे लेके फट जाता है. So that is because of inertia, the motion. तो ड्यू टू द mass mentioned, और mass की वजह से होता है inertia. ठीक है ना? So that is the right answer. So that is it for this video. I hope you enjoyed. Thank you for watching and please subscribe.